Okay, heat transfer for first year mechanical engineering students and for another students that help us to improve their knowledge. We are starting from this chapter 1. Chapter 1 is deals with heat transfer. That the content is introduction, conduction, heat transfer, forced convection transfer, natural convection, radiation, heat exchangers, boiling and condensation heat transfer. Introduction is how we can transfer heat from the one area to another area. That means from the system to the surrounding to the system. So heat transfer is done this way, from the surrounding to the system, from the system to the surrounding. So a system is interacting with its surroundings through heat and work transfer, or thermodynamics. Thermo means heat, dynamics is movement or motion. Heat transfer is the energy in the transit due to temperature difference between system and surrounding. Temperature difference is driving force for heat transfer. That means temperature difference is driving force for heat transfer. So we can see another introduction. The energy change of the system is related to the heat and work transfer according to this equation. Energy is this equation shows energy is equal to heat transfer minus work done by the system. Q stands for heat transfer, W stands for work done, this E stands for energy. Another one, heat transfer analysis has a number of applications in engineering and other aspects of life. For example, in human body, heat transfer through surrounding to human body, from human body to surrounding through in the form of conduction, convection, and radiation form. Many household equipment like air conditioning system, refrigerator, freezers, water heaters, iron, even the computers are the household equipment that heat transfer from the system to the surrounding. And energy efficiency, home design, optimal insulation thickness of the wall and roof, radiator, and engines of the automotive. The design of solar collector, various components of power plant, and even spacecraft. These are how tools that is heat transfer occur. Cooling, electronics equipment, chemical process, where is the energy or heat generation. The modes how we can transfer heat from one system to the surrounding, in the form of conduction, in the form of convection, and in the form of radiation. These three ways are the mode of heat transferring system. In all three modes of heat transfer, from a body at higher temperature to one at a lower temperature, that transfer is heat done between higher temperature area to lower temperature area, or higher temperature concentration area to lower concentration of temperature area. Except radiation, the other mode of heat transfer requires a medium for the heat transfer, as shown below in the figure. This one is the figures. Radiation from here to here, from here to here through conduction, from here to here through convection system, convection way of transferring modes. Heat transfer by conduction is due to interaction between particles of substance. More energetic particles transfer heat to lower energetic ones from higher energetic particles from lower energetic particles. Heat transfer can be done and the solid conduction due to vibration of molecules in the lattice and motion of free electrons. In liquids and gases, it's due to collision of molecules in their random motion. Experiment reveals that the rate of conduction heat transfer through a medium is dependent on mediums that heat transfer is dependent on geometry of medium, thickness of the medium, material property, temperature difference across the mediums. Those are tools that depend on those properties. Temperature difference from this one to this one. Higher temperature, this one T1 is very high temperature zone. This one also lower temperature zone. These are solid materials, as we can see. Conduction heat transfer. Conduction heat transfer rate can be expressed in the mathematical by Fourier's law. Conduction heat transfer rate, thermal conductivity of the material, cross-sectional area of the normal direction to heat flow. That is direction of heat flow. Temperature difference here from the T1 and T2. There are lengths here. Area is here. Conductivity of the material is here. So rate of conduction of heat transfer is expressed in this way. So the material or thermal conductivity of some materials are listed below. Diamond conductivity are 2300, and silver conductivity also 429, copper conductivity like this, gold conductivity like this, aluminum conductivity like this, iron, mercury, and glass, bricks, water, and air. Those are non-plastic materials. Our conductivity is very low because their property of the materials. So equation defined as above like this way expressed, and the next one is example here. We can do this example and we can solve our problems. So given temperature is here for 400 degrees centigrade, copper material is copper T1 and T3, stainless steel here, material is here, their conductivity is listed on above table. So we can solve this way. Then we can, after solving this problem, we can continue this convection heat transferring medium or way of transferring heat. We are continue at the next time or at the next slides. We can stop here. So to get more information, to get more slides and videos, you can subscribe this video and share for your classmate or your friends. And good day. Bye.